Welcome to Math Tutorials. In this video, we are solving every question of exercise 5.7 of Chapter 5, Continuity and Differentiability, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 5.7 has 17 questions on second-order derivatives, 10 direct computations, and 7 identities where y and its derivatives satisfy a differential equation. Here is the list. Question 1. A quadratic. Differentiate twice and watch it flatten to a constant. The second derivative is the derivative of the derivative. First derivative, 2x plus 3. Differentiate again, the constant 3 vanishes. Question 2. The 20th power, the power rule twice. Each differentiation pulls one exponent down. First, 20x to the 19. Second, 20 times 19. Question 3. A product of x and cosine, the product rule twice over. Watch the two sine terms combine in the second round. First, derivative by the product rule. Differentiate again. Minus sign, then the product rule on x sine x. Question 4. The logarithm. Its derivative is a power of x, and powers we know how to differentiate. First, 1 over x. Second, minus 1 over x squared. Question 5. X cubed times the log. Product rule, then product rule again. The x squared factors will merge neatly. First derivative, 3x squared log x plus x squared. Differentiate again. 6x log x plus 3x from the first term plus 2x. Question 6. An exponential times sine of 5x. Each differentiation mixes the pair. Collect sine and cosine coefficients at the end. First derivative. The exponential reproduces, sine gives 5 cosine. Differentiate again and add like terms. The sines collect to minus 24, the cosines to 10. Question 7. E to the 6x against cosine 3x. Bigger coefficients, same game. A common factor of 9 will appear at the end. First derivative. Differentiate again. Collect cosines 36 minus 9, sines minus 18, then factor 9. Question 8. The inverse tangent. Its first derivative is rational, and the chain rule handles the second. First, 1 over 1 plus x squared. Second, the chain rule on the reciprocal. Question 9. The double logarithm from exercise 5.4 returns for a second round. Differentiate its known first derivative as a product. First derivative, 1 over x log x. Second, the chain rule on the reciprocal of x log x, whose derivative is log x plus 1. Question 10. Sine of the logarithm, chain rule, then quotient rule. Sine and cosine of log x will both appear in the answer. First derivative, cosine of log x over x. Quotient rule. The numerator becomes minus sine of log x minus cosine of log x. Question 11. A combination of cosine and sine that must satisfy the oscillation equation. Differentiate twice and compare with the original. First derivative. Second derivative, exactly the negative of y. So the sum is 0, as required. Question 12. Inverse cosine, but the answer must be written using y, not x. After differentiating, substitute x equals cosine y, first and second derivatives in x. Since y is inverse cosine of x is cosine y, and 1 minus x squared is sine squared y. Substitute cosine over sine cubed, which is cotangent times cosecant squared, negated. Question 13. Cosine and sine of the logarithm. y1 and y2 denote the first and second derivatives. Multiply by x before differentiating again. That is the trick. First derivative, then multiply through by x to clear the fraction. Differentiate that product. Left side gives y1 plus xy2. Right side lands back on minus y over x. Multiply by x and rearrange. Exactly the required equation. Question 14. A general combination of two exponentials with rates m and n. Compute both derivatives and watch the coefficients factor and cancel. First and second derivatives bring down m and n once, then twice. Substitute into the combination. Group the e to the mx terms and the e to the nx terms. Each bracket collapses. M squared minus mn plus mn is 0, and the n bracket matches. Question 15. Two exponentials with rates plus and minus 7. Squaring the rates gives 49 on both terms. Differentiate twice. Each term picks up 7 squared, with the signs squaring away. Factor 49 from both coefficients. 49 times 500 and 49 times 600. That is 49y. Question 16. An implicit exponential relation with a striking conclusion. The second derivative equals the square of the first. Differentiate the relation, solve for the first derivative, then differentiate once more. Differentiate the product. E to the y times its derivative times x plus 1 plus e to the y. Differentiate that, plus 1 over the square. And the square of the first derivative is the same expression. Done. Question 17, the last one. The square of inverse tangent with a target equation in y1 and y2. Clear the denominator early, then differentiate the cleaned equation. First derivative by the chain rule, then multiply both sides by 1 plus x squared. Differentiate the product. 2xy, 1 plus the bracket times y2 equals 2 over 1 plus x squared. Multiply through by 1 plus x squared. Exactly the required identity. That completes all 17 questions of exercise 5.7. In the next video, we will take up the miscellaneous exercise on Chapter 5. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.